Okay, so let's talk about potassium correction in a hypokalemic patient. So let's say our patient has a currently is potassium has a potassium of 2.5, and the weight of the patient is 13 kg. So how do we know how to correct the potassium of this patient? So the first step is to calculate the potassium deficit, which means how much potassium is lacking in the patient. So potassium deficit is equal to the potassium, the target potassium minus the serum potassium times multiplied by the weight of the patient in kg multiplied by 0.4, which is a constant. So that will be, let's say our target potassium is 3.5. You can either take 3.5 or 4. Usually we take this is the minimum, the lower boundary of the normal value of potassium. So 3.5 minus the serum potassium, which is 2.5, times the weight, 13 kg, times 0.4. And we will get the number of 5.2, and the unit will be in millimoles. So the next step, so 5.2 will be the deficit, potassium deficit of the patient. So the next step will be calculating the daily maintenance of the potassium in this patient. So what is the formula of maintenance of potassium? It's 1.1 to 2 millimoles per kg. So let's say we take 1 in this case. So 1 millimole per kg, which is 13 millimole in this patient. So the next step be total calculating the total requirement of potassium, which the formula will be the deficit in A plus the maintenance in B. Deficit plus maintenance, which is 5.2 plus 13, which will be 18.2 millimoles. Okay, so this is the total requirement of the patient of potassium. Next step, we're calculating, we'll be changing the unit of millimoles into grams. So the formula would be divide by 13.3. 18.2 divide by 13.3, we will get the value of 1.4 grams. So now it's time for the correction part. Okay, so step E, correction. So correcting potassium, we need to know two rules. Okay, two rules. So rule number one is that the maximum concentration in a given correction of a solution in the peripheral line, peripheral IV line, should be 0.05 millimoles per mils. Um, Usually it's 0.05, sometimes it's written as 0.06 or 0.04. We will take the value of 0.05 in this case. And this would be also equal to about 60 millimoles uh, per liter, or 50 millimoles per liter, sorry. Should be 50 millimoles per liter. So this is rule number one. Rule number two would be that the maximum rate of correction should be 0.2 to 0.4 millimoles per kg per hour. This is the rate and this is the concentration. This is the maximum rate and the maximum concentration. Okay, so let's go back to our case. So let's calculate the dilution that we'll need. So how do we actually administer this potassium for this patient? So we know that the maximum concentration is 0.05 millimoles per liter. So this is 0.05 millimoles per 1 milliliter. And we know that our potassium in millimoles is 18.2. So 18.2 millimoles. So we want to know how much of the solvent that we need in this case, or in this case probably normal saline. So which is X. So X is also equal to 18.2 divided by 0.05, and we'll get 364 mils of solvent, which probably in this case it will be normal saline. So this means that we will give 18.2 millimoles of potassium in 364 mils of normal saline. But keep in mind that this is the maximum concentration, the maximum concentration that we'll be giving in, we should be giving in this patient. So we should go below this concentration. This is the maximum. 18.2 is also equal to 1.4 grams of potassium. This is the dilution. So next we'll calculate the rate of correction. So taking back the our formula 0.2 to 0.4, we'll take let's say we'll take 0.3 in the middle value. So 0.3 millimoles per kg over 1 hour is equals to 18.2 millimoles per x, which the x is the rate that we are giving, the number of hours or minutes that we are giving the potassium. We are correcting the potassium. So 0.03 per kg. This patient is 13 kg. We will get 3.9 millimoles in 1 hour. So we'll get the x by dividing 18.2 divided by 3.9. We'll get a value of 4.7 hours. So this means that we'll be giving be 18.2 millimoles of potassium over 4.7 hours, and this is the maximum rate that we should be giving. We shouldn't be giving less than for 4.7 hours. So this is all a very detailed correcting way that we calculate, but there is so let's give a conclusion of this. So the conclusion will be we'll be giving 18.2 millimoles of potassium in 364 mils of normal saline over 4.7 hours. This is the maximum dilution and concentration that we're giving. So in practice, we should be giving less than this value. So okay, 18.2 usually we just say for 1.4 grams, which will just round off to 1.5 grams. So in practice, we just say 1.5 gram of potassium in, let's say, because this is the maximum value, will be maximum dilution will be, we will want to give less than this, which will probably say about 400 to 500, let's say 500 mils of normal saline over, this is the maximum, so we shouldn't be going less than that, so we'll be giving over 5 hours, let's say 5 hours. So 1.5 grams of potassium in will be usually giving in potassium chloride, 1.5 gram of potassium chloride in 500 mils of normal saline over 5 hours. This is the actual calculation required to get the correction. But just to be easier, in adults, let's say in adults in 70 kgs or 60 kgs adults, we will, the common practice is just to give 1 gram of KCl in 100 mils of normal saline over 1 hour. Or we also can give 2 grams of KCl in 200 mils of normal saline over 2 hours. This is in adults. This is also what we call fast correction. So all that we have calculated here is actually for fast correction, which means that we want the potassium to be corrected, as the name implies, we want the potassium to corrected fast. In what cases that we want the potassium to be corrected fast is when the patient has severe hypokalemia, which arbitrarily defined by, let's say, less than, potassium was less than 2.5 or less than 2, or the patient is symptomatic, or there is ECG changes of hypokalemia. So we use fast correction. So the next we'll be talking about slow correction. So when do we use slow correction? Slow correction is when there is mild to moderate hypokalemia, which the potassium should be between 2.5 to 3.5, or I mean or 3, then we will consider using slow correction. And there is the patient is asymptomatic for hypokalemia and there is no ECG changes. then we would consider using slow correction. So let's give another scenario. So let's say our patient now is the weight is 10 kg, and the potassium currently is 2.5, and the patient is asymptomatic, and the ECG is normal, and can able to take orally, and able to tolerate orally. So the first step would be same. We'll be calculating the potassium deficit, the maintenance, the requirement, and then we'll be doing the correction. So again, deficit is equal to the target potassium minus the serum potassium multiplied by 0.4 multiplied by the weight, and which will get, let's say we want to correct to 4 this time. So let's say we take 4 minus 2.5 times 0.4 minus the 10. We get 6 millimoles of potassium. This is the deficit. Then we'll calculate the maintenance. So the maintenance will be same, 1 to 2 millimoles per kg, which is, in this case, we'll take 10 millimoles of potassium. So what is the requirement of potassium in this patient? We know that we take deficit plus the maintenance, which is 16 millimoles. So converting millimoles to grams again, we get 16 divided by 13.3, and we will get the value of 1.2 grams of potassium. Okay, so now to the correction part. So the correction part. So now we know that the patient needs 1.2 grams of potassium. How are we going to slowly correct this over, let's say, a couple of days, or a few couple of days usually? So there are two methods. The first method is we would use a tablet of potassium called slow K potassium tablet. This tablet is actually, there is 13.3 millimoles of potassium per 1 gram, but it's usually in the form of 600 milligrams. So that would mean that it is 8.1 millimoles of potassium per tablet. Then the second way is to correct by using mist KCl. This is a solution. This is a potassium in solution form, which has 1 gram of potassium in 10 mils, which is 13.3 millimoles. So now we know that these two forms of potassium is available. How are we going to prescribe this to this patient? So now we go to the part where we administer or prescribe the correction. So we know that let's say we want to correct using the tablet form. It's okay. 8.1 millimoles per tablet, we want to correct to 16 millimoles. So what is the number of tablets we will give? Actually, we don't need this calculation. We can just see that there is two. We just need about 2 tablets. So x about 2. So this means that we'll need 2 tablets of slow K to correct for this patient per day. This is for slow K. What if we want to correct using missed KCL? So 13.3 millimoles per 10 mils. This is the concentration of missed KCL. We want to correct to 16 millimoles. And what is the number of the volume of missed KCL that one will give? So 16 times 10 is 160. So 160 divided by 13.3 would be about 12 mils. So in conclusion, if we want to administer using tablet form slow K, we would use, so the first way we can correct is by prescribing tablet slow K 600 mg, because we know that 600 is 1 tablet, 600 mg, 2 taps per day. So it should be ED. And then the second method we can use is missed KCL 12 mils per day per day, or you can give by missed KCL 6 mils BED. This is OD or BED, or in any other division if which is not able to tolerate that much.